Example 4. Prove by mathematical induction 41 power n minus 14 to the power of n is divisible by 27. To prove that the statement by mathematical induction for n values, let me consider the proof for n is equals to 1, the first step. So for n is equals to 1, 41 to the power of n minus 14 to the power of n value is equals to 41 minus 14. And the value is 27, and that implies this number is a multiple of 27 which is divisible by. That implies this is divisible by 27. Divisible by 27. So let me assume that the statement for k values, let pk be true. Let the statement be true. So that implies 41 to the power of k minus 14 to the power of k is divisible by 27. It means that 41 to the power of k minus 14 to the power of k is a multiple of 27, m into 27. Okay, where m is an integer value, which implies 41 to the power of k is equals to 27m times plus 14 to the power of k. Taken this number to the right side, this can be written like this. That is the first condition. Now we have to prove, to prove that the statement p k plus 1 be true. Let the statement be true for k plus 1. To prove pk plus 1 be true. So that implies 41 to the power of k plus 1 minus 14 to the power of k plus 1 is divisible by 27. That means I have to prove that this is a multiple of 27 with the help of condition 1. Okay, consider 41 to the power of k plus 1 minus 14 to the power of k plus 1. Okay, this can be rewritten it as 41 to the power of k multiplied by 41 minus 14 to the power of k multiplied by 14. And I shall replace 41 to the power of k from the condition 1 as 41 multiplied by 41 to the power of k can be replaced by from here 27m plus 14 to the power of k minus 14 times 14 to the power of k. And that is written it as, opening the bracket, 41 times 27m plus 41 times 14 to the power of k minus 14 times 14 to the power of k. So in the next two terms, taken common 14 to the power of k. So that is equals to 41 into 27 times of m and plus 14 to the power of k common if you take up, it is 41 minus 14, the value is 27. So 41 to the power of k plus 1 minus 14 to the power of k plus 1 is simplified as, by taken common value, 27 times 41m plus 41m plus 14 to the power of k. So it is multiple of 27. That implies 41 to the power of k plus 1, 14 to the power of k plus 1 is divisible. Yes, it is divisible by 27, which implies statement is true for k plus 1. Therefore, Pn is true. The statement is true for all n belongs to capital N by mathematical induction. By mathematical induction. Hence, the proof.